What's happening, dogs? Mr. Allen here solving some quadratic equations in this video. And to do so, we're going to be using the quadratic formula because both of these problems are not factorable. That's my go-to method, but here we're going to be using the quadratic formula. So rule number one with the quadratic formula, got to be equal to 0. So let's change this one. I'll start on the right over here. I'm going to subtract both these terms, get it all over to the left-hand side, have it equal to 0. So minus 3x, we're going to add 12, and I'm going to have x squared minus 3x plus 12 equals 0. And now we can use our quadratic formula. It helps to identify a, b, and c. A right here is going to be 1, b is negative 3, and c is 12. If you'd like, you can also write it off to the side. A equals 1, b equals negative 3, and c equals 12. It can help you to stay organized when plugging into the beastly quadratic formula. All right, so see here, we got x equals the opposite of b, so positive 3. I don't know why I put plus 3, but positive 3 plus or minus the square root of b squared minus, so negative 3, b squared minus 4 times a times c, which is 12. Boop, make sure that it's all in there. All divided by, so that fraction line goes all the way, okay? All divided by 2a. So 2 times 1 because a is 1. All right. Now let's clean this thing up, shall we? We shall. We're going to have x equals 3 plus or minus the square root of negative 3 squared is 9. And then when I get to this like minus 4ac part, I like to figure out is it positive or negative first. 1 negative means it's going to be subtraction. Now it's just 4 times 1 is 4 times 12 is 48. All over 2. All right. So I like to do that with the 4ac because I see people screw up whether it's positive or negative all the time. So if I can just like break up the thought process there, I've got 1 negative. Nothing else is negative, so it's going to stay negative. If these were, if this was negative and that was positive, then I'd have a negative times a negative. I'd have positive. I'd put plus there, right? And I'd take care of that, and then I multiply my numbers, okay? Now, oh boy, we got ourselves a situation here, guys. Hopefully we can handle it. We got 3 plus or minus the square root of, and now it's 9 minus 48. What's that, negative 39? Over 2. Yeesh. Got a negative in the square root. Now, you may, actually, if you're encountering a problem like this, you've probably been introduced to imaginary numbers, right? You're really not going to throw this at you before you know them, or you might be like, no real solution. Okay? But we got imaginary numbers in our back pocket here. So I'm going to see if I can first off break this thing down. Ignore the negative for me. All right, let's see here. 39 is divisible by, not by 2, but by 3. I get 13. So no pairs, right? So the 39 can't break down, so instead, here's what we have, okay? I've got the 3 plus or minus. An I is going to come out for my negative inside that square root, and I'll have the square root of positive 39 now, all over 2. This is my final solution, okay? X equals 3 plus or minus I root 39 all over 2. Now, some will require you to actually, now that I think of it, sometimes they require you to write it in the a plus bi format, where you'd have it like this. Hopefully I have the room here. 3 over 2 plus or minus, and then it would be root 39 over 2 I think that's the most official way. X equals, that's the most official way to write the solution, where you have an a plus or minus bi, so a plus bi form. So you separate the real from the imaginary. That forms your overall complex number here. But I think most teachers, especially early on with the quadratic formula, are going to accept this version right here. But that is the mathematically official nerd version, okay? Cool? All right. Don't want to get called out by the super math nerds. I got an a plus bi form over there, bro. Back off. Back off. Everybody be cool. Everybody be cool. We're in imagination land. It's getting complex in here. Get it? Anywho, moving on. Let's do the next one. All right. So it's already equal to 0. Yay. Let's get our A, B, and C. Okay, so I like to do this. A, B, C. I don't like writing it down off to the side. You can if you want. That's what I do. I'm doing the math now. I'm just going to do how I want, okay? Everybody back off. So I got X equals opposite of B, so negative 2, plus or minus square root of, so 2 squared now, B squared minus 4 times A times C all over 2 times A. Cool. Okay. So now we got to do a little cleanup. I don't know why I'm closing my marker right now because I got a lot more math to do. Let's clean up the inside here and also my denominators. So we've got negative 2 plus or minus square root of, it's going to be 4 because 2 squared is 4. And then I know it's going to be a negative, right, because there's only one negative there. And I have 4 times 4 is 16 times 9. Okay, or I can think of it as like 36 times 4. Ooh, I like that. 36 times 4. 36 times 2 is 72. Double that is 144. All over 8. Okay, or you could grab your calculator. It's cool. Okay, no shame in grabbing the calculator. No shame in that game. I'm worried now that I did. I'm pretty sure I'm right. I'm pretty sure, right? I'm right. Yeah? 4 times 4 times 9? I'm right. We're good. We're good. Shouldn't have second guessed myself. Okay. So let us continue, children. Let's continue. So we got negative 2 plus or minus the square root of, that's what, negative 140? Should probably put the 1 there. Negative 140 all over 8. And now I'm going to try to simplify it. First off, I can't simplify these two. I'd have to have another one right here, like a 2 here or a 4 here, that can simplify with the 2 and the 8. Okay, so even if this is my final, I cannot break those two down and simplify. I have to have all 3 parts that can be simplified. Okay, so let's factor tree this thing. I'll use green since I did that last time. So here I'm going to have, let's see, I can break it down to 2 and 70. I'm ignoring the negative there because it's going to become my I, right? 2 and 35. And that's just going to be 5 and 7. It's a little tree that maybe like, it's like a palm tree, right? Big tropical storm bent it. Okay. Anywho, I got a pair of 2s. Yeah? Got a pair of 2s? Oh. The 5 and 7 are just chilling. So let's put this all back together. So I'm going to have negative 2 plus or minus. 2 is going to come out. I is going to come out. 5 and 7 get multiplied back together. People always ask, like, do I multiply them or do I add them? What do I do with them? I broke them apart with division. Got to put them back with multiplication. Okay? Over 8. And now, last step. The last thing here. I promise. Okay? We can divide everything here by 2. Right? This 2, that 2, and that 8. This 35 and the I and all that, that's all like one term. It's kind of like 2x. Right? I can divide by 2. So let's do that. I'm going to have negative 1 plus or minus 1i. So I root 35 over 4. Boom. That's it. I will also do it in A plus BI form for those of you that would like that. Okay, I'm happy to do so. Let's put a little equals. Negative 1 over 4. That's kind of nice. Negative 1/4. And then I have plus or minus. And it's root 35 over 4. Root 35 over 4 I. Okay, that is our official way of writing it. But again, I think either one's totally cool. Just more professional, okay? More nerdy, if you will. All right, that's it, guys. So there we go. Dealing with quadratic formula with imaginary solutions. Definitely can't factor for something like this right here. So quadratic formula is the way to go. It's foolproof, right? I mean, there isn't a quadratic that I can't use quadratic formula for. But it is time consuming, which is why we often look for solving using square roots or solving using factoring because it is a quicker method. It's not always going to work, right? Not every situation works that way, but if I can, I'll use those two. If not, quadratic formula in my back pocket, ready to rock and roll, opposite of b, plus or minus square root of b squared minus 4ac, all over 2a. See you later.